Hello. Today we are doing couple of questions from current electricity. Actually, I have given lots of questions from current electricity. You can see the question from the playlist. So try almost all those questions. You will learn a lot. Right. Today actually we are doing questions from Wheaton Bridge. Wheaton Bridge questions we at least get 1 or 2 in our paper. Remember that. Even meter bridge concept is from Wheaton Bridge. So we have to consider almost everything to do questions. So practicing Wheaton Bridge is really important when we do even electronic questions, because allocating potentials is being practiced in Wheaton Bridge method. Right, let's get into the questions furthermore, then I'll explain it to you later. Alright students, we are in our very first question. Here in the question they're asking us to find the resistance between A and B. Let's assume current goes from A to B like this. Now we all know it's a now, because from the topic actually we know it's a Wheaton Bridge question. Let's say let's start it from here. I hope you can see this point. This particular point and this particular point are connected by a wire. So that means we can connect it over here even. So that 9 and this 9 actually and this 72 ohms are parallel, starting from same point and terminate at the same point. And very same thing happening with the 6 ohms and 12 ohms. So these two are parallel. So 1 over 72 plus 1 over 9. I hope you know these methods now. So common denominator, that's 72. So 1 plus 8 equals 1 over 9, 72. Let's take the reciprocal value. We are getting R equals 72 divided by 9. That's 8. So in between here, now we have only 8 ohms. So in the very same method for 6 and 12, let's do the very same. 1 over 6 plus 1 over 12, common denominator, that's 12. 2 plus 1, take the reciprocal, 12 over 3, that's 4 ohms. So here we have 4 ohms resistance now, here. I hope this is clear to you. So here we have 4, here we have 8. Right, this is the Wheaton Bridge now. These 18 ohms. See, now current goes from A to B. So it goes in this way and this way. We need to check whether it's moved. Let's name another 2 points. Say now this is point C and this is point D. So the only thing we need to check is that whether there's a current flow between D and C, right? So let's see the Wheaton Bridge concept. 4:2 ratio here. It's 8:2, 1:2, sorry, 2:1, 2:1 ratio. That means there's no current through CD, so we can neglect these 18 ohms. So current will only pass to this way and this way. So 4 and 8, these two are in series, so 4, 8, that's 12, and these 2 and 4, that's 6, and these two are parallel. So 1 over 12 plus 1 over 6, same method, common denominator, 1, 2, take the reciprocal, 12 divided by 3, that's 4 ohms, easy answer. So we can get the answer is the first one. Students, we are in our second question now. Right, here they are asking us to find the resistance between P and Q. Right, this P and Q. Actually, this is not basically the what do you call it, Wheaton Bridge question, but it's quite similar to the question. It looks like a Wheaton Bridge question. You might think it like that. That's why I picked this question for you. Here, when actually just like the previous question we did, remember when things are connected, when points are connected by a wire, that means the potentials at these 2 points are equal. So in the very same manner, I can say the potential at this point and this point are equal. So I'll name this point as P as well, and this particular point it has to be P as well, right? So this is P and okay. So let's assume these R, right? So these 1 ohms, it's in between P and R. And again, of course, you can see this particular 1 ohms also, that's between P and R, right? and this one norms between P and Q. Of course, hope you can see this one norms is between P and Q, right? So I'll simplify this a bit like this. So in between PQ we have 1 norms, so this is P, we have 1 norms, Q, we have 1 norms here. And again we have in between PQ we have another 1 norms, that also here 1 norms, done, right? And between PR we have this 1 norm and this 1 norm, right? I'll draw it here again. R is in the middle, so 2 1 norms. Yes, middle R, right? And RQ we have another 1 norm. It's easy now, right? See, right? As you can see, this 1 norm and this 1 norm, these two are parallel. These two are of course parallel, and then this is in series. So I'll keep adding like 1 and 1. It's, I hope you understand, 1 and 1. It's 0.5, right? So that plus this one 1.5. So we have 1.5 ohms resistors in between PQ now. So we have 1, 1.5 and again 1 in parallel. So let's add them now. It's 101 plus 1.5 means 3 over 2, so reciprocal 2 over 3 plus again 101 equals 1R. Remember that the common denominator value, that will be, we need some space here, so the common denominator value will be 3. So here we get 3, here we get 2, again here we get 3, so the total value will be 8. So it's 3 over 8 ohms once we take the reciprocal value, right? So it's 3 over 8. It's the second answer. Right, now we are in our third question. Again students, this question looks like a Wheaton Bridge question. The diagram looks like that, but we need actually that concept. We do not need that particular theory actually. So in Wheaton Bridge question, let's say if this is x and y, the potential difference across x and y will be 0. But here there's a value, right, 4 ohms, but we need the concept, right? So again, so when doing this question, actually I'm going to ground it here. Let's say I'm going to ground it here. So the potential at this place will be 0 and here it will be 0. So at the same time potential here is 0 and potential here is 0, right? Then the potential drop across L is 7. The potential at this point x, it has to be 20 minus 7, that's 13 volt at point x. So potential drop here, here 4. So at point y it can be 17 and it can be 9 volt, either values, right? Remember that we don't know x with the which one is higher, x or y, right? The other values are not actually given. So the other values are not given, so we don't know whether this is 17 or 9, but from the answers let's try to pick the answer, right? Here it's 0, then the potential difference across M, it has to be 13 volt. That's obvious, that's correct. So across M it has to be 13. So we have 2 answers, second one and fifth answer, right? And of course let's say this is 17 here. So if it's 17 here, Q has to be 17. If it's 9 here, Q has to be 9. So let's check the answers. Here they are telling it's 7 across, across Q it's 13 at one point, cannot be. 9 is possible, right? Either it's 17 or 9, right? So it's 9. That's correct answer. If this is 9, then across this 20, so difference is 11. Across P it's 11. That's correct, right? So it's R. It's fifth answer. Actually students, allocating potentials, it's a key thing here in doing actually electricity questions and electronic questions as well. So if you are not familiar with these type of questions, I am suggesting you to try more questions until you become really familiar with these type of questions. Right students, we are in our fourth question now. This question, it looks like a Wheaton Bridge type question, because in some question you must have done these the potential between these 2 points are 0, so we can equate some of these likewise. There were questions like that, but this question is not exactly like that. We have to check it whether Wheaton is there or not. So when doing this question, let's start it from this side. That's how we have to start the question. Here these 6 ohms, 3 ohms are parallel. So as I mentioned you earlier, if the points are connected, let's say this is point C and this is point D, connected by a wire, the same potential remains. So here C, 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 and here it's D, here it's D, here it's D as well. So 6, 3, 2, CD, same name, that means these 3 are parallel. 106 plus 1 over 3 plus 1 over 2, take the common denominator 6, 1, 2, 3, so 606 1 ohms. So from this point to this point D, we have only 1 ohms, and we can remove now these values. It's not there, not there, not there, only we have 1 ohms within CD. And from D, here say this is E point, so DE we have 1 ohm. So 1 plus this one and this one are in series. So 1 plus 1, that's 2. That's 2 here. So between C, D we have 2 ohms. Right. Then again, from this C to E, we have, of course you can see only one resistor, this 2 ohms. 2 ohms and 2 ohms, these two are parallel. So 102 plus 102, that's 1 ohms. So between C and E, now we have only 1 ohms. Right. And now we are coming to this section. Again, let's say this is B and this point B. So BC, BC, we have 2 parallel resistors, 2 and 2, right? So once we had 2 and 2, that's 1, right? So we have between B and C only 1 ohms. So BC 1 ohms, CE again 1 ohm, right? Again we have only 1 ohms. So 1 plus 1, that's 2, and that's connected to this 2 ohm series. 1 plus 2 plus 2, that's 4. So between B and this point, say now A, that's 4 ohms. 4 plus 4, right? 104 plus 104, common denominator 4, it's 2. So 4 over 2, that's 2 ohms, right? So between these 2 points, we have 2 ohms. 1, 2, 4. 1, 2, 1, right? 1, 2, 3, 4, and here is 5. So total resistance R equals 5 ohms. So total current, it will be 5 divided by 5, it's 1 ampere, right? We are getting closer to our answer now. Current goes up to this point B, and here we have 4 ohms resistance path, right? And on the other side we have again, now the current is only 1 ampere, right? So it will come up to here, and from this point B, of course, it has 2 paths now, 4 ohms path, 4 ohms path. So what will basically happen is the current will split into 2 paths. So it's 102 amperes, that's the answer, that's the current through 4 ohms resistor. Right students, we are in our 5th question now. Right, here we actually have to consider the Wheaton Bridge for sure. Right, let's get into the question now. In the given electric circuit, the current through the resistance R1 and R2 in between current supply across X and Y ends are 3 ohms, 3 amperes and 2 amperes. Basically total 5 ampere current will pass through here. So what's the resultant resistance between point A and point B? Actually these values are not given, so we cannot add them. So from a certain data that they have given to us, we have to find this value, right? Right. So the only data that they are given is the resistance and the current as well. So potential, let's apply, there must be a Wheaton Bridge theory here. So 3 into 4, that's 12 volt. The potential drop here is 12 volt. Again 2 into 6, that's 12 volt. So potential drop is same. So kind of a Wheaton Bridge theory. So if the potential here, let's say, is E, so potential at A, it has to be E minus 12. And again the potential at this point, E minus 12. That means the potential difference
between R2 is 0. So that means there's no current through it. Wheaton concept, right? So if the potential difference is 0, the ratios has to be 0. That's Wheaton theory. So here is 4, here is 6. So that's 2:3 ratio, right? So here again we get 4, 6, correct, right? Yeah, 4:6, 2:3. So here we have 3 ohms resistor. So once all these are added, all these are added, the total resistance has to be 2, right, to match the ratio. So the answer, it has to be, first answer, 2 ohms. Students, I hope you have tried all these questions. If you haven't, again, it's your time to try these questions. I'm just showing you these questions actually for you to study. That means if you find any of these questions difficult, that means you haven't practiced that type of questions. So basically, what you have to do is you have to find similar type of questions and practice till you get comfortable with these type of questions.